close your eyes and imagine looking up at a sky filled with countless stars. They are steady, ancient points of light. But what if one of them blinked? Not like a planet passing in front, not a brief eclipse, but a strange, erratic dimming, as if something vast and unnatural were slowly turning in the void. What if this flicker was not a natural event, but a shadow? The shadow of a structure so large it could swallow worlds. Tonight, we journey towards these flickering stars. We are going to explore the quiet, breathtaking search for alien megastructures and the profound questions they raise about life in the cosmos. Before we travel to these distant suns, let us understand the idea that guides our search. In the mid-20th century, a physicist named Freeman Dyson asked a simple question. As any civilization becomes more advanced, its need for energy grows exponentially. Where does it find that energy? The ultimate source is its own star. Dyson imagined a civilization so advanced it could build a structure to capture nearly all of its star's energy. This concept became known as a Dyson sphere. It is not necessarily a solid shell, but perhaps a swarm of countless orbiting habitats and collectors, a cloud of engineering surrounding a sun. This is the mark of a truly mature civilization, one that has graduated from its home planet to harness the power of a god. To understand the scale of such a project, we can think of the Kardashev scale. It is a simple way to classify civilizations based on their energy use. A Type 1 civilization has mastered all the energy of its home planet. It can control the weather, prevent earthquakes, and draw power from the planet's core. By this measure, humanity is not yet a Type 1 civilization. We are still learning to manage our own small world. A Type 2 civilization is far beyond us. It has learned to harness the total energy output of its host star. This is where the Dyson sphere comes in. It is the ultimate power plant. A civilization that builds such a thing would have access to energy billions of times greater than our own. Their capabilities would seem like magic to us. They could move planets, ignite stars, and build worlds from scratch. And a Type 3 civilization? They've gone even further. They command the energy of an entire galaxy. They are galactic engineers, moving from star to star, perhaps building Dyson spheres around each one. To us, they would be indistinguishable from the fundamental forces of nature. Their existence would be written into the very structure of the cosmos. We are searching for signs of Type 2. For now, a single star wrapped in technology. So how would we find such a colossal structure? A sphere or swarm surrounding a star would block its visible light. The star would appear much dimmer than it should be, or it might disappear from our view entirely. But energy cannot be destroyed. The structure would absorb the star's heat, and it would have to radiate that heat away, or it would melt. It would glow, not in visible light, but in the infrared spectrum. Imagine a star that is mysteriously dim in our normal telescopes. But when we look at it with an infrared telescope, it shines with impossible brightness. It would be a ghost star, a silent, invisible beacon of heat in the cold of space. This is the signature we are looking for, a sign that something artificial is blocking the light and releasing the warmth. It is a very subtle clue hidden among billions of stars. The search for these signatures is like listening for a single, quiet whisper in a crowded room. Astronomers sift through immense catalogs of data, looking for anomalies. They use powerful telescopes to scan the sky, measuring the light from millions of stars, hoping to find one that behaves strangely. For years, this search yielded nothing but the quiet hum of the natural universe. Then came the Kepler Space Telescope. Its mission was to find exoplanets. It did this by staring at a small patch of the sky for years, measuring the brightness of over 150,000 stars with incredible precision. It watched for tiny, regular dips in starlight, the telltale sign of a planet passing in front of its star. Kepler found thousands of new worlds this way, but it also found something else. It found a star named KIC 846-285-2. Later, it became known as Tabby's star, after the astronomer who led the investigation. This star was unlike anything anyone had ever seen before. It was not dimming in a regular, predictable pattern like a planet would cause. Its light was dipping in strange, deep, and chaotic ways. Sometimes the star's brightness would drop by a small amount for a few days. Then it would drop by an astonishing 22%. A dip that large would require an object of immense size to block the light. For perspective, if the giant planet Jupiter passed in front of our sun, it would block only about 1% of its light. This was something else entirely, something enormous. The patterns were not just deep, they were irregular. There was no rhythm, no orbital clockwork to explain them. It was a chaotic flicker, as if a swarm of objects of different shapes and sizes were tumbling around the star in a disorganized cloud. The data was clean. The telescope was working perfectly. The star itself was a normal, middle-aged star. The mystery was what was orbiting it. Scientists immediately began to propose natural explanations. The first idea was a massive swarm of comets. Perhaps a passing star had disturbed the star's outer comet cloud, sending a cascade of icy bodies towards it. This can create a large, uneven cloud of dust and gas that would block the starlight in irregular ways. It seemed plausible. However, as they studied the star more closely, the comet theory began to show cracks. A cloud of comets and dust would be heated by the star, and it should glow brightly in infrared light. But when astronomers looked, the expected infrared glow was missing. There was no excess heat. Whatever was blocking the light was not behaving like a simple cloud of dust. Another idea was a planetary collision. Perhaps two large planets in the system had crashed into each other, creating a massive field of debris. This could certainly block a lot of light, but such an event would also create a specific kind of dust, a fine powder that would give off a particular heat signature. And again, that signature was not there. Maybe it was the star itself. Some stars have natural cycles of dimming and brightening, but Tabby's star was a stable F-type star, not the kind known for such dramatic variability, and the dimming was not uniform across all wavelengths of light, which which suggested something external was blocking the light rather than the star itself changing. There was also the theory of interstellar dust. Perhaps a dense cloud of dust just happened to be drifting between us and the star. But it would be an incredible coincidence for such a cloud to be so perfectly placed. And it would not explain the short, sharp dips in brightness, only a slow, gradual dimming. Every natural explanation seemed to fall short. This is when the most extraordinary hypothesis was put forward, very carefully and with many caveats. What if it was not natural? What if we were seeing an alien megastructure in the process of being built? A Dyson swarm. Not a complete sphere, but a collection of massive panels and habitats moving into place around their star. This would explain the irregular dimming. Different structures of varying sizes and shapes would block the light in chaotic ways as they moved along their orbits. It would also explain the lack of infrared heat. Perhaps this advanced civilization had found a way to radiate their waste heat in a highly efficient manner or in a direction away from us. It was a breathtaking thought. Imagine the scene. A silent cosmic construction site. Structures the size of continents gliding through the void, powered by starlight. A civilization taking its first steps towards becoming a true master of its solar system. We, from 1,500 light years away, were perhaps catching a fleeting glimpse of this monumental project. This idea, of course, is a massive leap. Extraordinary claims require extraordinary evidence. The search for extraterrestrial intelligence, or SETI, pointed its radio telescopes at Tabby's star, listening. They listened for any signal, any leakage of radio waves, any sign of intelligent communication. But all they heard was silence. The beautiful, cold silence of space. The lack of a signal does not disprove the theory. A civilization this advanced might use communication methods we cannot even imagine, like neutrinos or gravitational waves. Or perhaps they are simply quiet, content to build their world in peace, with no desire to broadcast their existence to the galaxy. The silence is just as mysterious as the flickering light. Since the initial discovery, other stars have been found with similar, though less dramatic, strange dimming patterns. They are often called dimming stars or flux dippers. Each one is a puzzle. Each one requires careful study to rule out all possible natural causes before we can even begin to whisper the word aliens. The most likely explanation for Tabby's star, according to many astronomers today, is dust, not from comets, but perhaps from the star itself, or from a destroyed planet or moon. A very fine, circumstellar dust that blocks light in a peculiar way. It is a less exciting explanation, but it fits the data without requiring a new form of physics or an unseen intelligence. But the mystery is not completely solved. The nature of this dust would have to be very unusual. It would have to be composed of particles of a certain size and shape to explain both the dimming and the lack of an infrared glow. It remains an anomaly, a beautiful puzzle that pushes the boundaries of our understanding of stellar systems. Let us drift away from the scientific debate for a moment and just imagine. Imagine living in one of those orbiting habitats. Your sky would not be a single sun. It would be a vast, intricate ceiling of other structures, with the brilliant light of your star filtering through the gaps. There would be no day or night, only a managed, gentle twilight. Your world would be a work of art and engineering. Your view would be of other manufactured worlds, gliding past on silent, perfect orbits. You would feel the gentle hum of technologies that draw endless energy from the star below. You would be part of a civilization that has transcended the limits of a single, fragile planet. From your window, you might look out into the deep black, and you might see a tiny, distant yellow star, a star like our own sun. And you might wonder if there is anyone looking back at you from a small blue world, wondering what is causing your star to flicker and fade, a quiet connection across an unimaginable gulf of space and time. The search for these megastructures is more than just a search for aliens. It is a search for our own possible future. It forces us to think about the long-term survival and evolution of intelligence. Will we remain on Earth forever? Or will we, in some distant future, reach for our own star and build a home among the planets? It is also a humbling exercise. It reminds us that the universe is not required to make sense to us. It is filled with phenomena that we do not yet have the words or the theories to explain. The strange dimming of a distant star could be a natural process we have not yet discovered, and that, in itself, is a beautiful and exciting possibility. Whether Tabby's star is shrouded in a cloud of cosmic dust, or a swarm of alien technology, it serves as a powerful symbol. It represents the unknown. It is a quiet whisper from the cosmos, reminding us that there are still great mysteries to be solved, and that we should never stop looking up and wondering. As you drift deeper into sleep, let this image stay with you. The image of a silent, distant star, wrapped in a veil of mystery, a star that reminds us that the universe is vast and strange and full of wonders that are still waiting to be discovered. The answer does not matter as much as the quiet awe we feel when we ask the question. So we are left with a profound cosmic mystery. On one hand, the tantalizing, almost mythical possibility of a Dyson swarm, a sign that we are not alone, a glimpse of a civilization far beyond our own. And on the other, the equally fascinating possibility of a new, undiscovered natural phenomenon, a type of cosmic dust or stellar behavior that will rewrite our astronomy textbooks. In the end, the search for megastructures is a beautiful testament to human curiosity. It shows our desire to find meaning and companionship in the great, silent emptiness of the cosmos. Whatever the truth may be, the flickering of that distant star has expanded our imagination and reminds us to always look for the unexpected. Thank you for joining this journey tonight. If you enjoyed this exploration of the cosmos, please consider subscribing and leaving a like to support our channel. Sweet dreams. And now, I leave you with a question to ponder as you sleep. What do you truly believe is hiding in the light of these strange stars? Is it a natural wonder or a quiet message from across the void?